to do stereo and Regio Selectivity. So what I did was these are in last Tuesday's folder as well. Also, the question came up, which mechanisms do you need to know? And I highlighted those on the version of this online, but I will just tell you right now that you will need to know the mechanism for next week of the, I'll just read the reagents. So HX, you'll need to know number 1. Number 2, HBr, H2O2, you will need to know. H plus H2O, number 3, you will need to know. H plus ROH, you will need to know, number 4. And then Br2 and Br2 in water. And those are the only mechanisms that you'll need to know for these additions. So HX, HBr, peroxide, H plus H2O, H plus ROH, Br2, and Br2 in water. So those are the mechanisms that I could ask you to do. Another question came up about the Br2 mechanism, because in the older exams I usually just ask for intermediates. The reason I only ask for intermediates is because with the dotted line to the bromine in the bromonium ion and triangular bromonium ion, there's just too many dotted lines. So asking for a transition state gets to be really confusing because what dotted lines go with what. So for those ones, I've just asked usually for a transition or for intermediates only, if you look at the older exams. I did move last night or yesterday. I didn't get a chance to before. I did move the all of the different problems of additions. I moved those to today's folder. So if you went to look for them a couple Fridays ago, they're now in today's folder, the practice problems. And people ask me, like, can you give us more practice problems? Maybe. But I think if you've made it through the first 100, well, that one makes it through the alphabet at least once. And I don't know that the bottom reactions I put on there, so I may do that as well. But the second part of those I asked for you to write the major product and then tell me whether it's Regio or stereo selective, both or neither. So that's what we're going to do today as well, outside of any questions that you have. The other question that's been asked is, can you make a list of topics for the exam? And sure, I can make that list. But wouldn't it be more beneficial if you made that list, starting with E2? I don't hear anybody saying yes, but I will. Yes, it would be more beneficial if you did that. Do you need incentive to do that? Sure, let's make that the assignment for Wednesday. Put together the list of topics for starting at E2. And you may say, "Wow, that's pretty evil." No, not really, because because that's one of the things that you need to do that will help it stick in your memory. If your notes are a little bit short, well, then you need to go back and either download my notes, the notes that I'm giving here, or I've given in class, or you need to go back to those sections. And if your notes are just, I've seen people walk into my office, and then all of a sudden this paper explodes on my desk. And they're not even hot messes, they're just messes. And I'm like, first thing you need to do before you prepare for this exam is you need to figure out what it is you're preparing for and what the material is. And then you can go about studying it. But when they bring in a folder and the paper just is everywhere, I'm like, okay, first thing is let's organize a little bit to figure that out. So that's why I'm asking you, because trust me, you will get more out of it if you come up with a list. Then I will create a list after that by taking a look at everybody else's list, or maybe I'll just copy somebody's list. My prerogative. So that's your assignment. Okay. And there's end of chapter topics in the book. There's table of contents. There's what we've done, reading assignments. Okay. All right, any questions to start with? All right, then that leaves it open for me. Let's say I give you these three reactions. And my question is, for each one of these, my question is going to be, write the major product of the reaction, and then tell me if it is regio, stereo, both, or neither. Okay. So for these first three, that's going to be the question. Actually, let's take these one at a time. So what you can do is come up and grab a little whiteboard. You can grab a whiteboard. I suppose I can hand out whiteboards, but it'd be more efficient if you guys came up and got them. Grab a pen, a whiteboard, and a cloth to erase. Don't everybody come up at once. And we'll do these one at a time. Okay, so for number A, you can discuss with the neighbor if you'd like, but what I'd like you to do is, first of all, tell me the major product. What would the major product be? And then what is it, regio, stereo, both, or neither? And then when you have your answer, you can hold it up and I'll acknowledge that I've seen it. Whether it's right or not, we'll hold off. Okay. So you need to tell me, is it Regio stereo volt? Those are your choices. I'm going to take a look at Regio Selective. I want to take a look and see if there's another product. And do I see peroxide in the product?
It's not stereo.
I want to take a look at the product. But then if you don't, then you might want to reconsider what your Regio okay. Now you want to look and see if you have all the products that all agree it's not stereo. You want to make You're sure about the stereo? And remember, you guys, now you have the listing of the reagents. So if you don't have that completely up here, you can always take a look at that listing and see if that helps. Okay, products, you might want to look whether it's Regio or not. Has everybody given me an answer so far? And remember, the farther away you are, the bigger you have to write for me to be able to see it. I think you're okay there. Okay, last call for answers. Okay, you might want to look for another product. Okay. Okay, let's take a look at A. Do you guys have a group answer? Okay. So, if this is a problem I'm going to give you next week, which I will, There's no ifs, ands, or buts. I will give you a problem like this. First of all, you can write as much mechanism as you need to get the final answer, but you are going to have to be able to write the final products and not go through a mechanism. So in this case, the easiest way to answer the question is, what am I adding to this double bond? What two groups am I adding to the double bond? And an H and a Br. Okay, how am I adding those? Markovnikov or anti-Markovnikov? Anti-Markovnikov, because the peroxide is there. If it's just HBr, it's Markovnikov. If it's HBr with peroxide, it's anti-Markovnikov. So which carbon should get the hydrogen then? In anti-Markovnikov, the carbon that is most substituted should get the hydrogen. Which carbon is that, the top or the bottom? They have the same number of hydrogens. So these two carbons have the same number of hydrogens, which is 0. So what does that mean? That means that I'm going to have two different products. I'm going to have adding the H to the top, the Br to the minus, adding the Br to the top, and the H to the minus, because there is no Markovnikov product. There is no major product in this case. This is then going to be 50-50. Now, I wrote it this way just in case there was a stereochemistry of the HBr addition. So I've added HBr, anti-Markovnikov. What's the final stereochemistry? What should they be added? Cis, trans, 50-50. 50-50, why did they get added 50-50? Because this reaction goes through what kind of intermediate? No. A radical. But as far as a radical or a carbocation, they're both sp2 hybridized intermediates. You'll see that I added notes to this chart. And so with that, that's number 2. Whenever you go through a radical or sp2 hybridized intermediate, what does that mean? That means you're automatically going to add it 50-50. How do I show that I added it 50-50? I don't show a stereochemistry. So I just show regular lines. Sometimes in the book you'll see that they may use a wavy line. That indicates both a bold and dashed wedge 50-50 if you see kind of the wavy line. But in this case there is no stereoselectivity for this. So is this stereoselective? No, because it's 50-50. Is it regioselective? It's not regioselective if this is 50-50. So this one is neither. It's neither stereo nor regioselective. Does that make sense to everybody? If it doesn't, you got to ask. I'll even put up Piazza if you need to ask something and you want to remain anonymous. Okay, so does that make sense? So if you drew in bold and dashed wedges and you showed 50-50 cis and trans addition, that would be perfectly fine. But when you do that, remember that it's 50-50, so you're going to want to somehow indicate to yourself that it's 50-50 so you don't think it's stereo selective. Okay. So yes, when you had 4 products there and you said, I don't have a major product, true. So what does that mean? That means it wasn't Regio and it wasn't stereoselective. And also remember that if you write a molecule with a chiral center, by definition, there will always be understood that there is the other enantiomer to that, because none of these reactions will make a chiral product, because we're not using a chiral reagent. Julia?
So if you drew all four of the products and put 25, 25.
Yes, that would be perfectly fine, because as long as you recognize there is no major product. All right, how about B then? Okay. You might want to go back and take a look at your, okay. Okay. Look at your product again. Okay. Tommy. Okay. 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 Wait, show it to me again. Okay. Now you need to deal with your neither regio, stereo, both or neither. Okay. Okay.
I mean, you do show the
Okay. Okay. What's 50-50 mean? What's the 50, Ty, what's the 50-50 mean? You might want to think about that. Okay. Okay. Okay, have I seen everybody's answers? You might want to think about your stereo selectivity. All right, last chance. Okay. Do I still see a little bit of a double bond there? That's better, except it's missing something. I think it's missing the methyl group. Okay, if I've seen everybody's that wants to show it to me. If you're not playing along. Okay, what am I adding? H2 palladium, what am I adding to the double bond? Preferably in some type of unison. What am I adding? 2 H's. Okay, I'm adding 2 H's to the double bond. Markovnikov or anti-Markovnikov? It's not applicable in this case. 100% cis, 100% trans. 100% cis. So whether you add it with 2 bold wedges or 2 dashed wedges, doesn't matter. It's 100% cis. Okay, so you could have the hydrogens on 2 bolds, 2 dashed. It doesn't matter. And actually, in this case, it doesn't really matter at all. I like to put in the groups, and then I put in my wedges. So in this case, the methyl group would be on a dashed wedge because I put the bold as the hydrogen. Okay, now, is this Regio Selective? Regio Selective? No, because symmetrical hydrogen. So I'm adding hydrogen, which is a symmetrical reagent. And so whether I add the hydrogens this way or this way, get the same product. So it's not regio. How about stereo? No? Why not? There's, okay. How many chiral carbons are in this molecule? Zero. There are 0 chiral carbons. Just because there's bold and dashed wedges doesn't necessarily mean that there are chiral carbons or that it's stereoselective. So you have to be careful about that. So in this case, there are 0 chiral carbons in this molecule. Now, whether there was 1 or 0, the reaction's not stereoselective, but the reason I'm kind of pushing on the 0 is, we did that last week, I think, right? And there was still lots of 1s, and today there's lots of 1s. So there's 0. Any mono-substituted cyclohexane ring, the mirror plane cuts through the chiral carbon, so it ain't chiral. So in this case, is this stereoselective? No, this is neither regio or stereoselective. Okay. So in terms of the flow chart then, what I did was, we talked last week about how you go through the process of thinking about stereo and regio selectivity. All I did in the flow chart was kind of give you the most direct pathway to that. So you can see it's not very much branched in terms of its stereoselectivity. The first thing is the reaction 100% cis or trans? If the answer to that is no, it's 50-50, forget about stereoselectivity. You can go through these reagents. Which ones were adding 50-50? The ones that went through carbocations, went through radicals. Everything else, the first 4 are 50-50, the rest of them are all cis or trans. They're cis or trans depending on the shape of the intermediate, or of the intermediate. So triangles are always trans, squares are cis, and the 5-membered ring is also cis. For the palladium, the hydrogen sits on the surface, the double bond comes down on top of it, it's going to add the hydrogen cis. So that's what the notes are. I gave you the intermediates there. And if you don't like this, you can definitely make one of your own. For whatever way you think. That's where it's going to be helpful in terms of preparing for the exam. There's a lot of stuff here. You could put them on 3x5 cards. You could put them on, I don't know, Quizlet or whatever, Anki or whatever you're using. If you're doing it on the computer, put it on 3x5 cards, put it on a piece of paper, organize it, whatever way makes sense to you. Because you have your own system. And I've been told never mess with a student's system. And a research student, she's like, don't mess with my system. And I am not going to mess with your system. But everybody has their own unique way of organizing things, and that's half the battle. Okay? Why is it that you can't get to medical school with a C in organic chemistry, which is BS? Been plenty of C students that have gotten to medical school. They're on my list of people not ever to make any medical decisions about me that I carry around in my wallet. Actually, I don't. But I knew. But a guy pulled it out of his wallet one time and showed me the list he had, which I thought was pretty extreme. Have I ever been in the emergency room when a former student has come in? Yes, one time. Fortunately, he was not on my list. But why do they say that? Why do they say organic chemistry? Why does somebody out there, some old school person, go, well, you've got to see an organic, you'll never make it to medical school? Again, BS phrase, but the reason is because you have such a large amount of material to organize that organic is sort of a preparation for that. Can you organize the material in a method that makes sense to you? Of course, this is a small amount of material versus the, piles that you get in any kind of graduate program. And usually there are people, they, divvy it up and they're working in teams. But it's how you organize the material. This is the first kind of reactions that we've had where it does organize very nicely into whether it's Regio, whether it's stereo, whether it's Markovnikov, anti-Markovnikov. So that's what I've tried to do here, but again, this has to make it from here to here. So, straight memorization, see the patterns, understand the reasons. I would like the third, but whatever way works for you is going to be the way you want to approach this. Okay. So in this case, I didn't create a chiral center. So if I look at that flow chart, yes, the hydrogenation is 100% cis. How many chiral carbons did I make? I made 0. Therefore, the reaction is not stereoselective. Even if I would have made 1 chiral carbon, it would automatically be in a 50-50 RNS. And so it would not have selected one enantiomer over another. The best I can do is have 2 chiral centers and select one diastereomer over another diastereomer. So that's why this flow chart works the way that it does. Okay. Is because you need 2 chiral centers to make diastereomers because that's what you're going to make one over the other. Are you going to make it 100% to 0? Yes. But there is no term for 100 to 0, except it's selective. Which, if you make the same decision consistently over and over again, I guess you're selective as well. Right? If you make 100 to 0 choice all the time, you're selective. If you make it 60-40, you're still selective. If you make it 51-49, you're still selective. So there is no term for 100-0. Okay. All right. So, does that kind of make sense? How about the third one? Try the third one and see what you get there. Okay. Miriam, let me see it again. Just so okay. And then I saw yours. Is there still remnants of a double bond there?
No, those are my chirals.
Oh, okay. 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 It's Br2 in water. Okay. 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 Wait, let me see that again. It's Br2 and OH. Or, sorry, it's Br2 and H2O that you're adding. Am I just not seeing the OH?
Yeah. Oh, yeah. But I'm
Okay. Okay, have I seen everybody's answer yet? Okay. Okay. Do you have bold and dashed wedges on that? Okay. Okay. Have I seen everybody's? Is there stereochemistries on there? Okay. Are you sure? Okay. Never mind. Okay. Okay, so what am I adding? And this is where you have to be careful. It's Br2 in water. So Br2 in water is a Br and an OH. Markovnikov or anti-Markovnikov? Neither, because the alkene is symmetrical. So I can add my Br and my OH to both places. And how am I adding my Br and OH? 100% trans, so I need the bromine and the OH to have opposite wedges. Okay. Yes? They do. They do add Markovnikov. But in this case, the two carbons have the same number of hydrogens. Now, if I would have reacted this one with the methyl group, then the Br would have added here and the OH would have added there. So then it would be Markovnikov. So anything that says it's Markovnikov, that assumes that the alkene is not symmetrical. But if the alkene is symmetrical, then there is no Markovnikov, anti-Markovnikov. Or better yet, it's 50-50. But I'm not going to get stereo. I'm not going to get any Regio selectivity. So in this case, is it Regio selective? No, because the alkene is symmetrical. Is it stereo selective? So if we look at the flow chart, is the reaction 100% cis or 100% trans? This one is 100% trans, yes. How many chiral carbons are in this molecule? There are 2 chiral carbons in this molecule. Therefore, this reaction is stereo selective. What's the other stereoisomer that I'm selecting here? So this is 100%, right? So the other stereoisomer that I am selecting against in this case is to have the Br and the OH added cis. That is 0% of the product. But is it a possible product? Yes. It's possible that the BR and the OH could add cis. Even though they add 100% trans, it's still possible. The basic definition of stereoselectivity means I have two possible stereoisomers. In this case, they are diastereomers. I am selecting one over the other. Therefore, it's stereoselective. Okay. So all this flow chart all boils down to that basic definition. Okay. Which, if you need to review that, it was, I did it twice last week. Similar, but not exactly the same. Julia?
If we're saying it's stereoselective, do we have to draw the option that's 0%?
No, you don't.
We can just draw that one and the one where OH is like on the top coming out of CDRs.
This one could have the bromine on top, the OH on the bottom, or vice versa, since it's symmetrical. The BR can be on a bold wedge, OH dashed, or vice versa. So what I'm going to grade this problem, I'm looking for this product where the bromine and the OH are trans. And it doesn't matter whether bromine's on top or the bottom, in this case. If I change this problem, though, let's say I change that problem and I say, okay, how about I put an ethyl group on the double bond, and now I add Br2 and H2O. Now I'm going to look at this and say, okay, what am I adding? I'm adding a Br and an OH. How am I adding that? Well, they normally add Markovnikov. What does that mean? Remember, it's a Br plus, and basically you can think of it as an OH minus, even though it's the entire water molecule that adds. So what's the electrophile? The electrophile is the Br plus. That is replacing H plus. So Markovnikov's rule would say, let's add the electrophile to the carbon with the most hydrogens in the double bond. Which one would that be? That would be the bottom one. So that I would add the Br to the bottom carbon, and I would add the OH to the top carbon. So this one would be Markovnikov. And so do I make two different products when I add the Br and the OH to two different ways? Yes. Am I selecting one? Yes. So this one would be Regio. How did I add the Br and the OH? 100% trans. So again, the Br and the OH have to be, in this case, bold and dashed. Did I make two chiral centers? Yes. This is also then stereoselective. Okay. Any questions? Does that kind of make sense? If I took any of those molecules and I said, let's go ahead and add like OSO4 and hydrogen peroxide to that, because I think those ones are missing from all of the different cyclohexene reactions. I don't think I did hydrogenation. I don't think I did OSO4 or CamNO4 in base, but I can put some of those problems together. In this case, would this reaction be regio or stereoselective? Well, we got to write the major product first. So in this case, OSO4 is adding what? Two OHs. Markovnikov, anti-Markovnikov, irrelevant because there's two OHs. 100% cis, 100% trans. 100% cis. So I'll put them both on bold wedges. Did I make two chiral molecules or two chiral centers in that major product? I did. So is this Regio Selective? No. Is it stereo selective? Yes. This is stereo selective. It is stereo selective.
For the problem above that one, isn't BR2 a symmetrical reagent?
It's BR2 and water.
Oh, okay.
So once I add the water, it's going to add BR and OH. So that's that's the one right below the BR2. Remember the BR, what happens is the BR comes in, forms a triangle, and then it's the water that comes in because it's the solvent, it comes in and adds to the triangle.
For the symmetrical reagent, that's only applicable for just the BR2?
Yes. Yes. You could go through and add more to this chart. You could say these reactions are going to be symmetrical. The ones that are symmetrical are marked neither in terms of Markovnikov, anti-Markovnikov. All of those ones that are marked neither are going to be symmetrical reagents. Okay. The other thing I will add to this problem is, because some of you were looking at this like, are there really two chiral centers? What is that product? Going back to our stereochemistry, what is this product right here? It's meso. So I guess if you need motivation, that's your motivation. So that is meso. So I wouldn't be surprised if in your top hat problems, if they don't give you a series of reactions and say, which of these reactions produces a meso compound? Right? If we're doing multiple choice format, that's a great question to ask. Because then you got to write the products of all four reactions, and then you have to remember what meso is. So you got to get the products right, and then you have to figure out which one the meso compound is. Of course, you could narrow that down just simply by saying only the reagents that give that are symmetrical are going to give you that. But then again, it could give you multiple ones. So just so you know, I mean, we can bring the stereochemistry back into play, which we already are by trying to determine how many chiral centers are there. Okay. All right. If you have any questions, put them up on Piazza. On Wednesday, we are going to start free radical halogenation, which may be on the next exam, or on exam 3, but that's not part of. You don't have to include that as part of your topics. I will add that or not add that on Wednesday. So on Wednesday, I will take a copy of your exam list, the exam topic list.